This is a WEG CFW100 Inverter Drive, and this is a 3-phase induction motor. In this video, I'm going to show you how you can use multi-speed control to set up to 8 speeds using the digital input terminals. Hello, I'm Simon from the Inverter Drive supermarket, and this video focuses on multi-speed control. By this we mean that combinations of digital inputs can be switched on and off to tell the CFW100 to run the motor at various predefined speeds. As in the previous video, I'm using WEG's 4-position pendant with switches representing each digital input. Up to 3 digital inputs can be used to set the output speed to one of 8 frequencies defined by parameters P124 to P131. To keep things simple, we're going to leave each at their default 50 Hz value. As you can see, these values range from 3 Hz to 55 Hz. Using only 2 digital inputs allows for 4 possible on-off combinations, as digital input 2 is always off. And using only 1 digital input allows for 2 possible on-off combinations, as the other 2 inputs are always off. For this video, I'm going to use digital inputs 2 to 4 for all 8 multi-speed references, with digital input 1 set to start-stop. So, as before, we'll need to modify parameters P263 through P266 to set the function of each digital input. First, let's set digital input 1 to run-stop. Press P to select the parameter list and navigate to P263. Press P again to select it. Set the value to 1 for run-stop and press P to save the changes. And press P again to acknowledge the conflict. Next, navigate to P264 and set the function of digital input 2. Press P to select it and set the value to 13 for multi-speed. Press P to save the changes. I'm going to do the same for P265, as digital input 3 also needs to be set to 13 for multi-speed. And the same again for P266 to set digital input 4 to 13 for multi-speed. And that's the digital inputs configured. I'm going to check that parameter P220 is set to 1 for always remote. This is to tell the inverter to use the I/O terminals rather than the integrated keypad. And I also need to set parameter P222 to 8 to tell the inverter that we're using multi-speed for the speed reference. This also clears the configuration error. So that's the parameters done. Let's try it out. First, I'm going to select parameter P002 so we can see the output frequency. All my switches are in the off position, so if I use digital input 1 to start the motor, it'll run at 3 Hz, as off, off, off is multi-speed ref 1. Multi-speed ref 2 is off, off, on, so if I switch digital input 4 on, the motor speed increases to 5 Hz. Multi-speed ref 3 is off, on, off, so if I switch digital input 3 on and digital input 4 off, the motor speed increases to 10 Hz. I'm not going to demonstrate every combination, I'll just jump to the last 2. Multi-speed ref 7 is on, off, so if I switch digital input 2 on, the motor speed increases to 50 Hz. Multi-speed ref 8 is on, so if I switch everything on, the motor speed should increase to 55 Hz. It doesn't. This is because the maximum speed set in P134 is 50. So let's increase P134 and try again. Before I do, I'll stop the motor and return the selection to multi-speed 7. Press P to return to the parameter list and select parameter P134. Increase this value to 55 and press P to save the changes. Now return to parameter P002 so we can see the output speed. Start the motor. It runs at 50 Hz, which is multi-speed ref 7 as before. Switch digital input 4 on, the motor increases to 55 Hz. And there we have multi-speed control. So how do we control direction of rotation? That's easy. We simply make the multi-speed reference negative. Let's try it out. Press the P key to return to the parameter list and select P124, multi-speed ref 1. Use the down key to decrease the value past 0 to -5 and press P to save. Select P002 so we can see the output frequency. Switch digital input 1 on to start the motor. It now runs anti-clockwise at 5 Hz and the screen shows the direction on the top left. This is the -5 value we just set for multi-speed reference 1, as digital inputs 2 to 4 are all off. Switch digital input 4 on to select multi-speed reference 2. You can see that the motor changes direction and is now rotating clockwise at 5 Hz, with the direction icon on the top left of the screen updated accordingly. Switch digital input 1 off to stop the motor. I'll switch digital input 4 off too. While the switches demonstrate how the digital inputs can be used to set any of the 8 possible multi-speeds, it's unlikely that this arrangement would be practical in a real application. You can't tell an operator, hey, make sure you set the speed switches to off, off, on, and then on, off, for example. It's not practical. A single switch with multiple positions would be better. To demonstrate this, I'm going to swap out the 4-position pendant for a 2-position version. As you can see from the labels, the left switch will run and stop the motor. This is using digital input 1 in exactly the same way as the 4-position pendant. The right switch is new and has 3 positions. The left position has a contact connected to digital input 3 behind it for multi-speed ref 3. The center position has no contact behind it, so we get multi-speed ref 1. And the right position has a contact connected to digital input 4 behind it for multi-speed ref 2. I'm going to set the speed for the 3 positions to slow, medium and fast. A real-world application could be to control the speed of a mixer, for example. The left position will be slow, so I'm going to set P126 to 10 Hz for multi-speed ref 3. The central position will be medium, so I'm going to set P124 to 30 Hz for multi-speed ref 1. And the right position will be fast, so I'll set P125 to 50 Hz for multi-speed ref 2. Let's try it out. I can use the run-stop switch to start the motor. The speed switch is in the slow position, so the motor runs at 10 Hz. When I move the speed switch to the medium position, the speed increases to 30 Hz. And when I move the speed switch to fast, the speed increases to 50 Hz. Simple. But we can go further and swap the pendants for a fully automated system. This is our Siemens logo demo rig, which contains a simple programmable controller and display. The controller has 4 outputs, which I've connected to the 4 digital inputs on the CFW100. The logo is going to represent a remote system which is controlling the CFW100 as part of some kind of factory process. The specific application is not important, so I'm going to use a program to get the motor to play the famous 5-note sequence from the movie Close Encounters of the Third Kind. This is the program I've created to do this. I'm not going to go into too much detail, but there are 2 inputs, F1 to start and F2 to stop and reset. These correspond to the 2 buttons on the TDE display here. Once the program is started, output Q1 is set, which is connected to DI1 on the CFW100. This tells the inverter to run. The program then runs through a sequence of 5 timers, with each timer triggering the next on a loop. They set the combination of outputs Q2 to Q4, which are connected to DI2 to DI4. I have already set the multi-speed references to the speeds required to best match the notes. To start the process, no interaction with the CFW100 is required. The operator simply presses F1 to start and... Not bad. But it'll sound a bit better if we can reduce or eliminate that high-pitched noise. We can do this by increasing the switching frequency. Select parameter P297 and increase the value from the default of 5 to the maximum of 15. This is going to triple the number of pulses on the inverter output, which will create a smoother looking sine wave in the motor and therefore reduce the noise. Press F1 on the display to start the program again. Oh, that's much better. That's it for this video. Thanks for watching, and be sure to catch the next one where we'll explore WEG's VVW sensorless vector control to improve low-speed performance. If you found this video helpful, please give it a thumbs up and consider subscribing, as we really appreciate your support. See you next time.